80,000 workers, 168,000 Merlin engines, the car driven by royalty, and the jet engines trusted by the world's airlines. Only Coca-Cola was a more recognised name on Earth. Rolls-Royce wasn't just a company, it was what Britain believed about itself. Then the engineers bet everything on a revolutionary jet engine with carbon fibre fan blades that had never been tested at this scale. The blades failed, costs tripled, every engine delivered lost over £100,000. On the 4th of February 1971, a Conservative government that had sworn never to rescue lame ducks nationalised the company within days. Today, the Derby factory where every Battle of Britain Merlin was assembled has been demolished. Only the marble hall stands, limestone columns in an empty postcode. This is the story of a self-taught orphan from a Greenwich poorhouse who built something that outlived him. An engine so ambitious it bankrupted its creator. And the retired engineers, all over 70, all veterans of the Merlin, who came back to save it. The greatest engineering company in British history, destroyed not by building a bad engine, but by building one whose triumph arrived too late. Chapter 1. The Boy from the Poorhouse. The story begins, as the greatest British industrial stories so often do, with poverty. Not genteel poverty. Not the polite kind that gets mentioned over tea and forgotten. The grinding, Victorian, workhouse kind. The kind that kills fathers and scatters families and leaves a 9-year-old boy standing at a graveside in Greenwich with nothing in his pockets and no one coming to collect him. Frederick Henry Royce was born on the 27th of March 1863 in Alwalton, Huntingdonshire, a village so small it barely troubled the map. He was the youngest of 5 children. His father, James, was a flour miller, a man who understood the rhythm of machinery and grain but couldn't hold a business together. By 1867, the mill had failed. The family fractured along the fault lines that poverty always finds first. James took the boys south to London, found work at a flour mill in Southwark, and for a few years there was something resembling stability. A wage, a roof, a routine. Then James Royce contracted Hodgkin's disease. He died in 1872 in a Greenwich poorhouse. Henry was 9. What followed wasn't childhood. It was survival. The boy sold newspapers on London streets for W.H. Smith, running copies through weather that would keep grown men indoors. He worked as a telegram delivery boy for the post office, threading through the city on foot, learning its rhythms the way only someone who depends on tips and speed can learn a place. London wasn't kind to him. But London taught him something. It taught him that the world didn't owe you a living, and that if you wanted to eat, you moved faster and worked harder than the person beside you. An aunt named Catherine changed the trajectory. She wasn't wealthy. She scraped together £20 a year, a sum that required real sacrifice from a woman of modest means. But it was enough to secure Henry an apprenticeship at the Great Northern Railway Works in Peterborough, and that workshop became the Crucible. Here, among the lathes and the forge heat and the smell of hot iron, the boy's nature declared itself. He crafted 3 miniature wheelbarrows in brass, tiny, exquisite things of obsessive precision, each one identical, each one perfect. Nobody had asked him to make them. Nobody was marking his work. He made them because something inside him couldn't tolerate the alternative. He rose before dawn to deliver newspapers, covering his living costs. He attended evening classes in English and mathematics, after full days on the workshop floor. He was, by every account, relentless, not with the frantic energy of ambition, but with the quiet, grinding persistence of someone who understood that stopping meant falling, and falling meant the poorhouse. Then Catherine's money ran out. November 1880. Henry Royce was 17 years old, his apprenticeship unfinished, his formal education consisting of roughly 1 year of schooling in his entire life. He walked from Peterborough to Leeds, walked because he couldn't afford the train, to stay with his sister. A teenage boy on a winter road with no qualifications, no connections, no family money, and 1 year of school behind him. By 1881, he'd found his way to the Electric Light and Power Generating Company in Suffolk. His wages doubled to 22 shillings a week. Still modest, but enough to fund evening classes at the City and Guilds Institute, where he studied under the physicist William Edward Ayrton. Royce was absorbing electrical engineering at night and practicing it by day, building a body of knowledge that owed nothing to privilege and everything to stamina. At 19, the company promoted him to chief engineer of a subsidiary in Liverpool. A teenager, effectively self-taught, running an electrical operation in one of the empire's great port cities. In 1884, with £20 of his own savings and £50 from his friend Ernest Claremont, Henry Royce founded F.H. Royce & Company in a workshop on Cook Street, Hulme, Manchester. The initial products were domestic electric fittings, lamp holders, switches, the small components of the electrical revolution, then transforming British homes and factories. Then dynamos. Then electric cranes. The company incorporated as Royce Limited in 1894 and went public in 1899. Each step was methodical. Each product was over-engineered. Royce's maxim, repeated so often it became the company's philosophical foundation: take the best that exists and make it better. His second maxim, whatever is rightly done, however humble, is noble. He meant it. He meant it so completely that it destroyed his health. Royce was a compulsive worker, the kind of man who couldn't walk past a problem without stopping to solve it, couldn't see an imperfection without reaching for a tool. He ate badly. He slept worse. He drove himself with a ferocity that his colleagues admired and his doctors despaired of. The precision that made his products extraordinary was the same precision that made his body a machine. He ran far beyond its tolerances. On his deathbed in 1933, the night before he died, Henry Royce sat up and sketched a shock absorber design on the back of an envelope. He instructed his nurse to ensure the boys in the factory got it safely. The last act of his life was engineering. The poorhouse boy died as he had lived, working. Chapter 2. The Midland Hotel. His counterpart could scarcely have been more different. If Royce was poverty compressed into purpose, Charles Stuart Rolls was privilege set loose upon the world. Born on the 27th of August, 1877. At 35 Hill Street, Berkeley Square, one of the finest addresses in London, Rolls was the third son of Lord Langattock, a Welsh baron whose family estate at the Hendray sprawled across the Monmouthshire countryside. He was educated at Eton and Trinity College, Cambridge, where he studied mechanical and applied science and became the first undergraduate to own a motor car. That detail alone captures the man. He wasn't simply wealthy. He was wealthy and obsessed, a motoring fanatic who held speed records, made over 150 balloon ascents, and earned the nickname Dirty Rolls from his habit of tinkering with engines until his hands were black with grease and his clothes were ruined. In January 1903, with £6,600 from his father, a sum that would have kept the Royce family fed for decades, Rolls opened C.S. Rolls and Company at Lily Hall, Fulham. It was one of Britain's first car dealerships, selling imported French and Belgian vehicles to a clientele that could afford continental engineering. But Rolls was desperate to find a British-made car as good as the foreign models. It wasn't patriotism exactly. It was something more personal, the conviction that British engineering could match anything from the continent, if only someone with sufficient talent and sufficient bloody-mindedness would build it. The bridge between these two worlds, the self-taught perfectionist from the poorhouse and the aristocrat's son from Berkeley Square, was a man named Henry Edmonds. A fellow Royal Automobile Club member and director of Royce Limited, Edmonds had bought one of the 3 10-horsepower cars Royce had built based on a dismantled French Decauville. Royce had taken the Decauville apart, studied every component, identified every flaw, and rebuilt the thing from scratch. Not as a copy, but as a correction. Edmonds drove the result, recognised its quality immediately, showed it to Rolls, and arranged the meeting that changed British industrial history. On the 4th of May, 1904, at the Midland Hotel, Manchester, the aristocrat and the self-taught engineer met for the first time. The Midland Hotel was the grandest building in Manchester, red brick and terracotta, with a winter garden and a French restaurant, and the kind of marble-floored confidence that the Edwardian age built into its public spaces. Rolls arrived expecting competence. What he found was something else entirely. The 2-cylinder car Royce had built was, by every technical measure, superior to anything Rolls had sold from the continent. The engine was smoother, the tolerances were tighter, the finish was immaculate. Rolls was deeply impressed, and Rolls was not a man who impressed easily. By the 23rd of December, 1904, they had a formal agreement. Rolls would take all the cars Royce could make, and they would be badged as Rolls-Royce. On the 15th of March, 1906, Rolls-Royce Limited was registered with capital of £60,000. Royce became chief engineer at £1,250 per year. Rolls became technical managing director at £750. The partnership was not equal in title or salary, but it didn't need to be. Royce built the cars, Rolls sold them. The arrangement was clean. But there was a third figure in this founding, a man without whom neither the engineering genius nor the aristocratic salesman would have built a legend. Claude Goodman Johnson took the same terms as Rolls and would prove more consequential than either founder imagined. Johnson was the commercial genius who turned engineering excellence into mythology. Born in 1864 in Datchet, educated at St. Paul's School and the Royal College of Art, he had organised Britain's first motor exhibition in 1896 and served as secretary of the Automobile Club. He was a large, broad-shouldered extrovert who gave himself the title the hyphen in Rolls-Royce, and meant it literally. He was the connection between the thing Royce made and the way the world perceived it. It was Johnson who took the 12th 4050 horsepower chassis off the production line and transformed it into something beyond a motor car. He painted it in aluminium paint, fitted silver-plated hardware to every visible surface, and named it the Silver Ghost. The name alone was a stroke of marketing genius. It promised silence, elegance, something almost supernatural in its refinement. But Johnson didn't stop at naming. He orchestrated the 1907 reliability trial that made the Silver Ghost immortal. 15,000 miles of observed driving between London and Glasgow, 27 consecutive round trips, smashing the previous endurance record of 7,089 miles. The cost of servicing after 7,000 miles was £2, 2 shillings and 7p. Autocar magazine examined the evidence and delivered the verdict that Johnson had been engineering from the start. The best car in the world. Johnson ensured that phrase appeared in every Rolls-Royce advertisement for decades. He hadn't just marketed a car. He'd created a brand identity so powerful that it would outlive the company itself. Henry Royce's tribute to Johnson was unequivocal. He was the captain and we were only the crew. In March 1908, Johnson persuaded the board to move from Manchester to a new factory on Nightingale Road, Derby. The choice was strategic. Cheap electricity from the Derby Corporation, skilled labour drawn from the town's railway workshops, and sufficient space to grow. The 12.7-acre factory, designed to Royce's own modular steel frame specifications, opened formally on the 9th of July 1908. Johnson also drove the one model policy, concentrating the entire company's resources exclusively on the 40/50 horsepower Silver Ghost. No distractions, no compromises. One car, made as close to perfectly as human hands and precision tooling could manage. In 1911, Johnson commissioned the sculptor Charles Sykes to create the mascot that would become the most recognisable hood ornament in the world. The Spirit of Ecstasy, a woman leaning forward with arms swept back like wings, was almost certainly modelled on Eleanor Velasco Thornton, the secretary and lover of Lord Montague of Beaulieu. The figure captured something essential about the brand Johnson had built. Grace in motion, beauty serving purpose, the romantic elevated to the mechanical. Charles Rolls didn't live to see the mascot unveiled. He had resigned as technical managing director in April 1910, his attention consumed by a newer obsession, aviation. On the 12th of July 1910, at a flying display in Bournemouth, the tailplane of his Wright Flyer broke off at 100 feet. He was killed instantly. He was 32 years old, the first Briton to die in a powered aircraft. The aristocrat was gone. The company he'd co-founded was barely 4 years old. But Royce was still at his drawing board, Johnson was still building the legend, and the Nightingale Road factory was just beginning to understand what it was capable of. Chapter 3. The Eagle and the Empire. The war that came in August 1914 transformed Rolls-Royce from a luxury car maker into something altogether more consequential. The board resisted at first. Ernest Claremont, the chairman, Royce's oldest friend, the man who'd invested that original £50 in 1884, thought the war would be over by Christmas. Most of the country thought the same. But Henry Royce, working from his home in Kent, where his fragile health increasingly confined him, saw the aeroplane as the future of warfare, and the Aero engine as the future of Rolls-Royce. He didn't wait for the board to agree. He started designing. The first drawing for what would become the Eagle engine was released on the 16th of September 1914, just 43 days after the decision to build Aero engines. That pace tells you something about Royce's method. He didn't commission studies, he didn't convene committees, he drew. The Eagle was a water-cooled 60-degree V12, a configuration that would become the signature Rolls-Royce architecture for decades. It first ran in February 1915, producing 225 horsepower, and by 1918 had been developed to 360 horsepower. A total of 4,681 Eagles were built during the war. Combined with the smaller Falcon, 2,185 built, and the Hawk, 204, Rolls-Royce produced roughly 5,000 wartime Aero engines, accounting for nearly half the air horsepower used by Allied forces. That statistic bears a moment's weight. A luxury car company from Derby, employing a fraction of Britain's industrial workforce, was responsible for nearly half the power keeping Allied aircraft in the sky. The Eagle's most celebrated moment came after the war ended. On the 14th of June 1919, Captain John Alcock and Lieutenant Arthur Whitten Brown climbed into a modified Vickers Vimy biplane at St John's, Newfoundland. The aircraft was powered by two Rolls-Royce Eagle 8 engines. 16 hours and 12 minutes later, after flying through fog, sleet and ice so severe that Brown had to climb out onto the wing to clear the air intakes, they crash-landed in a bog at Clifton, County Galway. The first non-stop transatlantic flight. The engines had run without failure for the entire crossing. Rolls-Royce had proved something that went beyond any sales brochure. Its engines could be trusted with your life at the extremes of human endurance. That reputation, reliability not as a marketing claim but as a demonstrated life-or-death fact, would define the company for the next half-century. The interwar years brought expansion and the first taste of American ambition. In 1920, Rolls-Royce opened a manufacturing venture in Springfield, Massachusetts, producing cars for the American market. Over 11 years, 2,944 vehicles rolled off the Springfield line. Beautiful machines, meticulously built, each one carrying the interlocking RR badge, into a country that understood luxury but had never encountered this particular strain of British obsessive precision. The Depression killed the venture. The Springfield plant, which had cost $440,000 to build, was sold for just $65,000. America would feature again in the Rolls-Royce story, under very different circumstances. In 1931, Rolls-Royce made an acquisition that captured the company's competitive instincts perfectly. Bentley Motors, the legendary racing marque founded by W.O. Bentley, winners of Le Mans 5 times in the 1920s, had collapsed into receivership. Napier, the rival engine maker, was the expected buyer. Rolls-Royce moved through a front company, purchasing Bentley for £125,000. W.O. Bentley himself didn't know the identity of the buyer until the deal was done. He arrived for work to discover he was now employed by his greatest competitor. The acquisition secured Bentley's assets and, more importantly, eliminated a rival. It also planted Rolls-Royce's flag in a slightly different market segment, a positioning that would matter enormously decades later when the company was carved apart. But the critical achievement of the interwar years wasn't commercial, it was technical, a chain of engine development that would lead, link by link, to the machine that won the Second World War. Arthur Rowledge, recruited from Napier in 1921, designed the Kestrel, a supercharged V12 that first ran in 1926 and produced 450 horsepower, eventually reaching over 700. The Kestrel was a formidable engine in its own right, powering the Hawker Hart family of biplane bombers. It also, in one of history's bitter ironies, powered the prototypes of the Messerschmitt Bf 109 and the Junkers Ju-87 Stuka, the very aircraft that Rolls-Royce engines would later be called upon to destroy. The enlarged Buzzard, at 36.7 litres, became the basis for the R racing engine, built in only 19 examples. Each one a handcrafted weapon designed for a single purpose, winning the Schneider Trophy. The international seaplane race was, by the late 1920s, an undeclared war between nations fought with fuel and aluminium rather than bullets. Italy, under Mussolini, poured state resources into winning. Britain nearly withdrew, until Lady Houston, the eccentric millionaire and aviation enthusiast, personally donated £100,000 to fund the British entry. The man who led the racing engine development was Ernest Hives, and his story matters as much as any engine blueprint. Chapter 4. The Bloody Plumber. Ernest Walter Hives was born on the 21st of April 1886, in Reading, the 12th child of a factory clerk. 12th. In a household where every mouth at the table meant a thinner slice, where ambition was a luxury and survival was the curriculum. Hives left school at 12 and found work at a local garage, where he discovered an aptitude for engines that amounted to a kind of fluency. He could listen to a motor running and hear what was wrong the way a musician hears a wrong note. In 1903, he fixed Charles Rolls' broken-down car on the road, and Rolls, recognising talent with the instinct of a man who'd grown up around the best of everything, hired him on the spot. By 1908, Hives was at the Derby factory as an experimental tester, having reportedly flipped a coin on Midland Road to decide whether to continue to the factory or turn around and go home. The coin landed in Rolls-Royce's favour, and, as it turned out, in Britain's. He rose to head of the experimental department by 1916, still in his 20s. Known internally as HS, the two-letter abbreviation that appeared on his memos and became his identity within the company. Hives was the antithesis of the image Rolls-Royce projected to the world. Where the brand spoke of silver and spirit and ecstasy, Hives described himself as just a mechanic, just a bloody plumber. He drove a modest Hillman rather than a Rolls-Royce. His directive to subordinates was stripped of any pretension. Work till it hurts. But behind the self-deprecation was a mind of extraordinary clarity. Hives understood that Rolls-Royce's future lay not in perfecting existing designs, but in pushing beyond them. And the Schneider Trophy campaigns became his proving ground. The R engine was a monster, the Kestrel's mild-mannered cousin enlarged and supercharged into something that produced staggering power from a block you could barely stand next to when it was running. The heat was extraordinary. The noise was savage. The fuel consumption was irrelevant. These engines were built to run flat out for the duration of a race and then be stripped down. Every component a forensic record of what extreme performance did to metal and oil and air. On the 13th of September 1931, a Supermarine S-6B seaplane, powered by the R engine, won the Schneider Trophy for the third consecutive time, securing it permanently for Britain at a speed of 340 miles per hour. 16 days later, the same aircraft set a world airspeed record of 407.5 miles per hour, the first aircraft in history to exceed 400 miles per hour. The R engine had proved that a Rolls-Royce power plant could operate at the absolute frontier of what was physically possible. The lessons about supercharging, about cooling, about metallurgy under extreme stress fed directly into the next generation. The Schneider Trophy didn't just win a race, it built the knowledge base that would save a civilization. The engine that emerged from this lineage was designated P-Phi-12, a private venture funded by the company's own resources rather than government contract. It was a 27-litre V12, a development of the Kestrel, not, as myth would later hold, a derated R engine. It first ran on the 15th of October 1933 at the Derby factory, producing 790 horsepower. Its first flight came on the 21st of February 1935 in a Hawker Hart biplane. It was named Merlin, after the Falcon, Falco columbarius, per the company's convention of naming piston engines after birds of prey. The final design for the PV-12 was fixed on the 22nd of April, 1933. That was the day Henry Royce died. The boy from the poorhouse, the self-taught engineer who had only 1 year of formal schooling, whose hands had built the Silver Ghost and the Eagle and the Kestrel and laid the foundations for everything that followed. He was gone. The Merlin would carry his legacy into the skies over southern England, where the survival of the nation would depend on whether Rolls-Royce engines could outperform anything Germany could build. Both the Spitfire and the Hurricane were designed around the PV-12. R.J. Mitchell at Supermarine and Sidney Cam at Hawker had each shaped their fighters to exploit the engine's slim profile and high power-to-weight ratio. The airframe and the engine were not separate achievements, bolted together. They were conceived as one integrated system, and that integration would prove decisive. But the Merlin, in its early form, was not yet the engine that would win the war. Its supercharger, essentially unchanged since 1934, was deeply inefficient, with a side entry duct forcing air through sharp 90-degree turns that bled energy at every corner. The engine needed more power at altitude, where the air was thin and the fighting happened. It needed someone who understood the mathematics of airflow the way Royce had understood the mechanics of metal. That someone arrived in January 1938. His name was Stanley Hooker, and Ernest Hives greeted him with a line that became legend. "Not much of an engineer, are you?" Hooker was born in 1907 in Sheerness, Kent, the son of a farm labourer. He'd earned a DPhil in aerodynamics from Oxford, a mathematician by training, not a mechanic. Hives was sceptical of academics, but Hives was also smart enough to know that the problems facing the Merlin couldn't be solved by instinct alone. They required the kind of theoretical understanding that turned fluid dynamics from art into science. Hooker found the supercharger's efficiency was roughly 68%, meaning nearly a third of the energy being fed into compressing air was being wasted in turbulence and friction. He redesigned the intake, the impeller blades, and the diffuser vanes. The efficiency rose to 76%. The overall power improvement was approximately 30%. The resulting Merlin 45 powered the Spitfire Mark V, the most produced Spitfire variant of the entire war. Then Hooker went further. He designed a revolutionary two-stage supercharger, 2 impellers in series, each one boosting the air that the other had already compressed. The resulting Merlin 61 could develop 1,000 horsepower at 30,000 feet. It was fitted to the Spitfire Mark IX, which arrived in service just in time to counter the Fokker-Wulf FW-190, a German fighter that had been making existing Spitfire marks look inadequate over the Channel. By late war, Merlins in de Havilland Hornets produced 2,050 horsepower each. Bench tests reached 2,640 horsepower at emergency boost. A compact 27-litre engine was outperforming Germany's 34-litre Daimler-Benz DB605 at altitude. Thanks to superior supercharging, higher revolutions per minute, 3,000 versus 2,500, and access to 100-octane fuel shipped from the United States. Ernest Hives, now General Works Manager and Board Director, understood that engineering brilliance meant nothing if you couldn't produce engines in the quantities a global war demanded. Derby alone could never build enough Merlins. The factory on Nightingale Road was assembling every Merlin-engined aircraft's power plant for the Battle of Britain. But the Battle of Britain was just the beginning. What was coming would require industrial mobilization on a scale that no single factory, however devoted, could achieve. Hives made his most consequential decision, splitting motorcar and Aero engine operations and driving the creation of shadow factories for mass production. The age of the craftsman's workshop was over. The age of industrial warfare had begun, and the fields and farmland around Derby, Crewe, Glasgow and Manchester were about to be transformed into the engine rooms of survival. Chapter 5. 168. 1,000 engines. The fields came first, then the concrete, then the machines, then the people, thousands of them, tens of thousands, arriving by bus and bicycle and on foot from the terraced streets of towns that had never built an Aero engine and were about to build more of them than anywhere else on Earth. The Crewe Shadow Factory was built from May 1938 on the potato fields of Merrill's farm on Pims Lane, a site chosen not for glamour but for geography. Crew sat on the railway lines connecting it to Derby, which meant tools, parts, drawings, and engineers could move between the two sites quickly. The town had a deep pool of skilled labour drawn from its railway engineering tradition. Men who understood precision metalwork, who could read a technical drawing and hold a tolerance, who knew what it meant to build something that other people's lives depended on. Within 5 months of the first foundations being poured, the first Merlins were rolling off the Crew line. 5 months. From potato field to production engine in less time than it takes to plan a house extension. The urgency was real. By the summer of 1940, with the Luftwaffe massing across the Channel, every Merlin-engined aircraft defending Britain had its engine assembled at the Derby factory on Nightingale Road. Derby was the single point of failure for the entire air defence of the nation. If a bombing raid knocked out Nightingale Road, the Spitfires and Hurricanes would have no engines. The shadow factories weren't a convenience. They were an insurance policy against extinction. At peak production in 1943, 10,000 workers at Crew were producing Merlins at extraordinary rates. The factory roof and walls were painted in camouflage patterns designed to resemble ordinary streets and houses when seen from the air, a deception aimed at Luftwaffe reconnaissance aircraft flying at altitude. The company built workers' houses on Selworthy Drive, Smith Grove and Rolls Avenue, streets that remain family homes today, their names the only visible trace of the factory's wartime parentage. Total Crew Merlin production across the war, 26,065 engines. The Glasgow factory at Hillington was larger still. Built from August 1939 on 150 acres of farmland on the outskirts of the city, it was the biggest shadow factory of the entire war. 14 separate blocks, each covering 3 acres, connected by concealed walkways that kept workers under cover as they moved between departments. At peak, Hillington employed between 16,000 and 25,000 workers. The numbers vary by source because the workforce fluctuated with the war's demands, with shifts running around the clock. 2/3 of those workers were women. That single fact reshaped the social fabric of industrial Glasgow. Women who had never held a spanner, who had been told their entire lives that heavy engineering was men's work, were machining crankshafts, assembling cylinder blocks, testing fuel systems. They worked punishing 82-hour weeks. Their day off was 1 half Sunday per month. The pace was relentless because the arithmetic was relentless. Every Merlin that didn't reach an airfield was a fighter that couldn't fly. A young engineer named Denning Pearson served as technical production engineer at Hillington, overseeing output of 150 Merlins per week. He was methodical, driven, technically precise, qualities that would carry him to the summit of Rolls-Royce and, ultimately, to the centre of its catastrophe. But that was decades away. In 1943, Pearson was simply one of thousands of people bent to a single purpose: build engines, win the war. Total Hillington production: 23,675 Merlins, with a single-day record of 100 engines. Ford's factory at Trafford Park, near Manchester, contributed another 30,428. Stanley Hooker, the mathematician who transformed the Merlin supercharger, later acknowledged with characteristic generosity, "Once the great Ford factory started production, Merlins came out like shelling peas at the rate of 400 per week. And very good engines they were too. Yet never have I seen mention of this massive contribution." Across the Atlantic, the Packard Motor Car Company in Detroit produced 55,523 Merlins under a $130 million contract. Packard had been selected after Henry Ford, whose initial offer had raised hopes of massive American production, reneged, reportedly unwilling to build engines for the British. The Packard 5, 1650 variant, transformed the P-51 Mustang from a mediocre, low-altitude fighter into the supreme long-range escort of the war, enabling the first fully escorted, deep-penetration bombing raid on the 13th of December, 1943. An engine designed in Derby, built in Detroit, fitted to an American airframe. The Merlin had become an instrument of Allied strategy on a global scale. Total Merlin production across all factories: 168,176 engines. They powered over 40 aircraft types: the Spitfire, the Hurricane, the Lancaster, the Mosquito, the Mustang, the Halifax, and dozens more. No single engine in the history of aviation has been built in such numbers, fitted to such a range of aircraft, or deployed across such a breadth of theatres. The figure is so large it becomes abstract. Try it another way. At peak combined output, the shadow factories and their partners were producing more than 1,000 Merlins every week. 1,000 engines, each one a hand-assembled masterpiece of 27 litres and over 1,000 horsepower, leaving factory floors every 7 days. Ernest Hives led the wartime effort with a ferocity that cost him everything except the work itself. His son, Pilot Officer Edward Hives, was killed in action with RAF Coastal Command in October 1940. Hives received the news and returned to his desk. There is no record of him taking a day off. Air Vice Marshal Sir Wilfrid Freeman, the man responsible for RAF procurement, said of him, "That man Hives is the best man I have ever come across. God knows where the RAF would have been without him." The Derby factory on Nightingale Road was bombed on the 27th of July 1942. A lone Dornier Do 217 dropped 4 bombs on the site. 12 people died in the factory. 11 civilians in the neighbouring streets were also killed. 9 air raids targeted the Nightingale roadworks during the war, but this was the only one to strike the Aero engine buildings. The dead were buried. The damage was repaired. Production continued. Chapter 6. The Women Who Fought Back. The women who built Merlins at Hillington were not passive contributors to someone else's war effort. They knew their worth, measured it in engines per week, in tolerances held, in the sheer physical endurance of 82-hour shifts. And when they discovered that worth was not reflected in their wages, they did what British workers have always done when the arithmetic of fairness doesn't add up. They organised. Agnes MacLean was a crane driver at the Hillington factory, born in 1918 in Ibrox, Glasgow, the kind of woman whose strength was forged in the tenement streets of a city that did not raise its daughters to be timid. In 1941, she led a strike winning women the right to join a trade union at the factory. That alone was a victory in an industry that had viewed women's presence as temporary, a wartime expedient to be reversed when the men came home. MacLean saw it differently. If women were building the engines that kept Spitfires in the sky, women deserved a seat at the table where conditions and wages were negotiated. 2 years later, the injustice became impossible to ignore. Women at Hillington, earning 43 shillings per week, discovered that men performing identical work, the same machines, the same tolerances, the same shifts, received 73 shillings. The gap wasn't subtle. It wasn't hidden. It was 30 shillings a week, staring them in the face every payday. MacLean organised again. Approximately 16,000 employees joined the strike. The numbers are staggering for a single factory action during wartime. The strike lasted roughly a month. It cost an estimated 730,000 working hours. Some local women who hadn't joined pelted the strikers with vegetables, furious about the impact on war production. The tension was real and raw, patriotism colliding with justice, national survival set against basic fairness. Rolls-Royce capitulated. The company agreed to pay based on the job performed, not the gender of the person performing it. It was the only major women's equal pay strike of the entire war. The principle MacLean and her colleagues fought for, equal pay for equal work, would take another 3 decades to become law across Britain. At Hillington, it became reality in 1943, because 16,000 people decided that building the engines that defended the nation entitled them to be treated as the nation's equals. Meanwhile, at the Royal Aircraft Establishment in Farnborough, a different kind of problem was being solved by a different kind of engineer. The Merlin had a critical deficiency in combat. During negative G manoeuvres, a sudden dive, a pushover to evade a pursuing fighter, the carburettor would flood, the fuel supply would cut, and the engine would cough and die at precisely the moment the pilot needed full power. German engines fitted with fuel injection rather than carburettors suffered no such weakness. A Luftwaffe pilot could push his stick forward and dive with full power. A Spitfire or Hurricane pilot who tried the same thing risked a dead engine and a very short future. Beatrice Tilly Schilling, an engineer at Farnborough, designed the fix. A simple brass restrictor ring fitted into the carburettor float chamber, limiting fuel flow during negative G conditions, enough to prevent flooding while maintaining adequate supply for normal flight. The device was nicknamed Miss Schilling's Orifice by pilots and ground crew, the kind of irreverent humour that RAF culture specialised in. It was a stopgap, not a permanent solution, but it worked immediately and saved lives. Schilling was a motorcycle racer who held a gold star from Brooklands for lapping at over 100 miles per hour. She understood engines not as theoretical constructs, but as machines that people depended on at the limits of their courage. In early 1943, at the Swan and Royal Hotel in Clitheroe, Lancashire, Ernest Hives struck one more deal that would shape Rolls-Royce's future for decades. Over dinner with Spencer Wilkes of the Rover Company, Hives negotiated a swap. Rover would take Rolls-Royce's Meteor tank engine plant in Nottingham. Rolls-Royce would take Rover's jet engine factory at Barnoldswick, where Frank Whittle's revolutionary turbojet was being developed amid chronic production delays and engineering friction. A handshake sealed the agreement. The official handover came on the 1st of January 1943. Within weeks, Rolls-Royce achieved 10 times Rover's runtime hours on the Whittle W2B engine. The difference wasn't magic, it was culture. The same culture of testing, refining, and testing again that had taken the Merlin from 790 horsepower to over 2,000. Hives had secured Rolls-Royce's entry into the jet age over a dinner table in Lancashire. Among the engineers who transferred from Rover to Rolls-Royce was Adrian Lombard, a name that meant nothing at the time and would come to mean everything. Chapter 7. The Jet Age and the Spirit of Ecstasy. After the war, the transition came fast. Rolls-Royce moved from piston engines to jet propulsion with the same methodical ambition that had carried it from electric cranes to Aero engines 3 decades earlier. The Welland, just 167 built, powered the Gloucester Meteor, Britain's first operational jet fighter. The Derwent and Nene followed, the Nene gaining notoriety when examples exported to the Soviet Union were reverse-engineered as the Klimov RD-45, powering the MiG-15 that would later face American fighters over Korea. British generosity, or naivety, handing jet technology to a future adversary. The irony was not lost on those who'd spent the war ensuring Rolls-Royce engines outperformed everything the enemy could field. The crew factory was handed to the motorcar division. The first vehicle off the post-war crew line was a Bentley Mark VI in 1946. A different kind of machine from a Merlin, but built in the same buildings by many of the same hands, with the same institutional expectation that tolerances would be held and shortcuts would not be tolerated. Derby concentrated on what it now did better than almost anyone on Earth: developing jet engines. The Avon, Rolls-Royce's first axial-flow turbojet, ran for the first time in March 1947 and remained in production for 24 years. Over 11,000 were built. The Avon powered the English Electric Canberra, the Hawker Hunter, the de Havilland Comet 4, the Vickers Valiant, the English Electric Lightning, and the Sud Aviation Caravel. A single-engine design, versatile enough to serve bombers, fighters, and airliners across 2 decades. That was the dividend of the culture Hives had built, not just brilliant individual designs, but an engineering philosophy that produced platforms capable of evolution. The Conway broke new ground entirely. Proposed by Chief Engineer A. Griffith, a theoretician whose work on gas turbine cycles had helped lay the intellectual foundations for jet propulsion, the Conway became the world's first turbofan engine to enter airline service. The concept was revolutionary. Instead of pushing all the air through the hot core, a proportion was bypassed around it, producing thrust more efficiently and more quietly. The Conway powered Boeing 707-42Os, Douglas DC-8-40s, and the Vickers FIV C-10. The elegant rear-engined airliner, beloved by BOA, sea crews and passengers for its quiet cabin and impressive short-field performance. The Spey turbofan followed, powering the BAC 111, the British Phantom, and the Blackburn Buccaneer. accumulating over 50 million flight hours in service. A figure that speaks not to any single spectacular achievement, but to the grinding, day-after-day reliability that airlines and air forces demand from engines they stake their reputations and their people's lives upon. At Crewe, the motorcar division was crafting machines that maintained the mythology Johnson had built half a century earlier. The Silver Cloud, produced from 1955 to 1966, 7,372 built, was the last of the separate chassis Rolls-Royces, a car whose proportions and presence carried the unmistakable message that its occupant had arrived in every sense. The car that replaced it represented a revolution disguised in conservative clothing. The Silver Shadow, launched in 1965, was Rolls-Royce's first monocoque construction. The body and chassis integrated into a single structure, a technique that the rest of the industry had adopted years earlier, but that Rolls-Royce had refined through 10 years of development and over 1 million test miles before committing to production. It featured self-leveling hydropneumatic suspension licensed from Citroën and four-wheel disc brakes, technologies that placed it at the engineering frontier while its exterior whispered tradition. The Silver Shadow became the best-selling Rolls-Royce ever built. 30,057 units across its production run. Its 6.75-litre V8 engine, first designed in 1959, would remain in production in modified form for over 60 years. The longest-serving engine architecture in automotive history. A 1987 marketing survey would find that only Coca-Cola was a more widely recognised global brand name than Rolls-Royce. Consider that. A company founded with £60,000 in 1906 by a self-taught orphan and a baron's son had built a name that rivaled the most ubiquitous consumer product in human history. The interlocking RR didn't just represent a car or an engine. It represented an idea. That British engineering, at its best, was the finest in the world. That precision, pursued without compromise, produced something that transcended mere machinery. For the communities that depended on Rolls-Royce, the brand's prestige was translated into something more tangible: stability. In Derby, the company shaped streets, funded apprenticeships, anchored social clubs and civic institutions. Multi-generational employment was common. Grandfathers, fathers and sons passing through the same gates on Nightingale Road. Each generation inheriting not just a job, but an identity. In Crewe, the pattern repeated. The factory that had been built on potato fields to fight Hitler had become the town's economic spine. A job at Rolls-Royce wasn't just a wage. It was a position in the world. The quiet, unshakable pride of building something that bore the most respected name in engineering. The company was described in the press as that sturdy bellwether of Great Britain's industry, the heart and spirit of British engineering. David Huddy, who had joined Rolls-Royce as a young stress analyst in 1939, later reflected, Rolls-Royce had a towering reputation, which was deserved. The emphasis was his. In 1945, it didn't need justifying. By the mid-1960s, it would need defending. Chapter 8. The Colossus Lord Hives. Made Baron Hives of Duffield on the 7th of July 1950, in recognition of his wartime leadership, served as chairman until 1957. He died in April 1965, aged 78. The bloody plumber from Reading who had flipped a coin on Midland Road, who had lost his son to the war and worked on without pause, who had secured the jet age over dinner in Clitheroe. He left behind a company that stood as one of only 3 enterprises on the planet capable of developing large jet engines from scratch. The other 2 were American, Pratt and Whitney and General Electric. Between them, these 3 companies held a monopoly on the technology that made modern civil aviation possible. No one else could do it. The barriers, in metallurgy, in aerodynamics, in testing infrastructure, in accumulated institutional knowledge, were so high that no new entrant had a realistic prospect of joining the club. Rolls-Royce's seat at that table wasn't inherited. It had been earned, engine by engine, from the Eagle, through the Merlin, through the Avon and Conway, across half a century of continuous development. The man who occupied the chair in the mid-1960s was Sir Denning Pearson, the same Denning Pearson who had overseen Merlin production at Hillington as a young engineer. Born in 1908 in Bootle, orphaned at 11, he'd won a first-class degree from Cardiff and joined Rolls-Royce in 1932. His rise through the company was methodical. Technical roles in production, then management, then the board, and finally chief executive and chairman. Pearson understood the Aero engine business with the intimacy of someone who had built the engines with his own hands before managing the people who built them. Beside him was Sir David Huddy, born in 1916 in County Cavan, Ireland, a Trinity College Dublin mathematics graduate who had joined Rolls-Royce in 1939. Huddy was the managing director of the Aero engine division, a man of sharp analytical intelligence whose personal decency was noted by everyone who worked with him. He would later spend months in the United States, making 250 individual trips, totaling 3 million miles, selling the engine that would destroy the company. That campaign hadn't started yet, but the forces that would make it necessary were already in motion. In October 1966, Rolls-Royce acquired Bristol Siddeley engines for £63.6 million. Bristol Siddeley was itself the product of a 1959 merger between Bristol Aero Engines and Armstrong Siddeley, a consolidation of Britain's second-tier aero engine capacity into a single entity. The acquisition brought 10,000 additional employees, the Pegasus engine powering the revolutionary Harrier jump jet, the Olympus powering the Vulcan V bomber, and, in its adapted 593 variant with Snecma, Concorde, plus factories at Filton, near Bristol, and at Coventry. Pearson drove the acquisition because he feared the alternative. Bristol Siddeley was negotiating to license Pratt & Whitney's JT9D engine, the power plant chosen for the Boeing 747. If that deal went through, an American engine would be manufactured on British soil by a British company, creating what Pearson called an American Trojan horse in the domestic market. Rolls-Royce would face a competitor with American technology and British production costs, undermining its position from within. The acquisition was defensive, strategic and, at £63 million, expensive. But it achieved its primary objective. Rolls-Royce became Britain's sole major aero engine company, the only British enterprise capable of competing with the American giants on equal technical terms. By the mid-1960s, the numbers told the story of a colossus. Rolls-Royce employed between 73,000 and 80,000 people across Derby, Crewe, Bristol, Glasgow, East Kilbride, Barnoldswick, Hucknall, Leavesden and other sites. It was Britain's 14th largest company by manpower. Engines bearing the interlocking RR-powered aircraft for the Royal Air Force, the Royal Navy, over a dozen foreign air forces, and major international airlines. The spirit of ecstasy adorned cars owned by the royal family, heads of state, and celebrities. The company was a national institution, not merely an employer, but an embodiment of what Britain believed about itself. Adrian Lombard, the engineer who had transferred from Rover in 1943, was now Director of Engineering. Born in 1915 in Coventry, Lombard had no formal aerodynamics training. He was, like Royce before him, a self-made engineer whose intuition for what would work outstripped anything a textbook could teach. He had championed both the three-shaft engine concept, 3 concentric shafts, allowing each compressor section to spin at its optimum speed independently, and composite materials, specifically carbon fibre, as the future of fan blade construction. His colleagues regarded him with something approaching reverence. He was the man who could see around corners, who knew which engineering problems would yield to persistence and which required a fundamentally different approach. Lombard's vision would define the engine that Rolls-Royce bet the company on, and his death would remove the one person who might have navigated the crisis that followed. Standing at the summit in 1966, Rolls-Royce looked unassailable. 80,000 employees, the only British aero engine maker, one of only 3 companies on the planet that could build a large jet engine, a motorcar division whose products were synonymous with perfection, a brand name rivaled only by Coca-Cola, a heritage stretching from the poorhouse to the palace, from the Merlin to the Mach 2, Concorde, but the wide-body jet age was coming. aircraft that would carry 250 passengers across oceans, aircraft that needed engines of a size and power never before attempted. American Airlines had already approached Lockheed and Douglas with specifications. General Electric and Pratt and Whitney were developing their bids. And Rolls-Royce, standing at the peak of its power, was about to make a decision born of the same quality that had made it great. The absolute conviction that its engineers could build anything, solve any problem, push any frontier, and that the money would somehow follow. That conviction had built the Silver Ghost, the Eagle, the Merlin, and the Conway. It had won the Schneider Trophy, the Battle of Britain, and a seat at the top table of global aerospace. It had never failed. Which was precisely why, when it did fail, nobody inside those walls saw it coming. Chapter 9. The Widebody Gamble. The challenge arrived from across the Atlantic in 1966, and it carried the weight of inevitability. American Airlines had approached Lockheed and Douglas with specifications for a new kind of aircraft, a widebody jet capable of carrying 250 passengers across transcontinental and intercontinental routes. The economics of air travel was shifting. Airlines wanted bigger aircraft with lower seat-mile costs, and the airframe manufacturers were racing to deliver them. Boeing had the 747, already committed with Pratt & Whitney's JT9D engine. McDonnell Douglas was developing the DC-10 with General Electric's CF-6. Lockheed, absent from the civil airliner market since the disastrous L-188 Electra turboprop, a program plagued by fatal crashes and catastrophic reputation damage, was desperate to re-enter with the L-1011 TriStar. The TriStar needed an engine. A new generation high-bypass turbofan in the £40,000 thrust class. Bigger, more powerful, and more efficient than anything that had come before. 3 companies on Earth could bid. General Electric offered the CF-6. Pratt & Whitney had the JT9D. And Rolls-Royce offered something that existed, at the time of bidding, largely on paper and in the mind of Adrian Lombard. The RB211. Lombard's design was revolutionary in ways that went beyond incremental improvement. It was the first production 3-spool engine, 3 concentric shafts, each carrying its own compressor and turbine section, each spinning independently at its own optimum speed. Where General Electric and Pratt & Whitney used 2 shafts, Lombard used 3, promising superior efficiency across the entire operating range, a shorter and stiffer engine structure, better part-load performance and, critically, enormous growth potential. The architecture could be scaled up over decades, producing engines of ever greater thrust from the same fundamental design. But the feature that gave the RB211. Its decisive competitive edge was the fan blade. Lombard had championed Hi-Fill, a carbon fibre composite material developed from technology at the Royal Aircraft Establishment, Farnborough. Carbon fibre was dramatically lighter than titanium, and the fan blade is the single heaviest rotating component in a turbofan engine. If you could make the fan blades from carbon fibre instead of titanium, you could save hundreds of pounds of weight. And weight, in the Aero engine business, is the currency that buys everything else. A lighter engine means a lighter aircraft, means lower fuel costs, means more profit. Per flight means the airline buys your engine instead of the competition's. The weight advantage was the reason Lockheed chose Rolls-Royce. Daniel Horton, Lockheed's chairman, a former systems analyst from Alabama who had risen through the company's ranks to become chairman on the 2nd of May, 1967, selected the RB211 because the 3-shaft design and carbon fibre blades promised the TriStar a distinct performance edge over the DC-10. The TriStar's S-duct air intake was specifically designed around the RB211's cross-section. Switching to a different engine later would mean redesigning the entire rear fuselage. The 2 companies were locking themselves together. David Huddy moved to the United States in 1967, dedicating himself to selling the engine with a personal commitment that bordered on the sacrificial. 250 individual trips. 3 million miles of travel. The marketing campaign alone cost £840,000. Huddy believed in the engine because he believed in Rolls-Royce's engineering culture, the same culture that had taken the Merlin from 790 horsepower to over 2,000, that had transformed the Avon into a 24-year production run, that had never failed to deliver on its promises. On the 29th of March 1968, the contract was signed. Rolls-Royce would deliver 540 RB211-22 engines at a fixed price of approximately £230,000 per engine. The contract guaranteed £42,000 of thrust. The delivery deadline was September 1971. Late delivery penalties were included. Lockheed announced initial orders for 144 TriStars, 50 from Eastern Airlines, 44 from TWA, 50 from Air Holdings. The original estimated development cost was £65 million. The UK government provided launching aid covering 70%, up to £47 million. The numbers looked manageable. The technology looked achievable. The customer looked solid. Denning-Pearson's justification for the bid became the most quoted sentence in British aerospace history. Building a new engine would not guarantee we stayed in business. Not building one would certainly guarantee that we went out of business. The logic was sound, the price was not. David Huddy's own assessment, given later, "I thought the price was keen, but I thought we would make money." Academic analysis would conclude, with the blunt clarity that hindsight affords, that Rolls-Royce's success in winning the contract was based on price cutting. The company had deliberately underbid to secure the order, gambling that engineering excellence would close the gap between the price they'd quoted and the cost of actually building the engine. It was the most consequential bet in British industrial history. And the one man who might have made it work was already dead. Chapter 10. The Man Who Wasn't There. Adrian Lombard collapsed at his desk on the 13th of July 1967, 8 months before the RB211 contract was signed. He was rushed to the Derbyshire Royal Infirmary, where he died of a cerebral hemorrhage. He was 52 years old. The visionary who had championed both the three-shaft architecture and the high-full carbon fibre technology, the man whose intuitive engineering judgment had guided Rolls-Royce's most ambitious designs for 2 decades, was gone. He died before the contract was signed. He died before the first test run. He died before anyone discovered how far the gap stretched between what the RB211 promised and what the state of engineering knowledge in 1968 could actually deliver. Aviation writer Bill Gunston, one of the most respected technical journalists of his generation, later wrote with devastating precision. It was all too obvious that the Derby engineers, normally proud and self-confident to the point of arrogance, had slid from bad to worse when their great leader, Lombard, had been so suddenly plucked from them. Many inside the industry believed that the RB211's problems could have been solved earlier had Lombard lived. Not because he possessed some magical ability, but because he possessed something rarer, the authority, born of proven judgment, to make hard decisions quickly. To say, this approach isn't working, abandon it, try this instead, to cut losses before they became catastrophic. Lombard was the man whose word the engineers trusted absolutely, and without him the technical problems multiplied while the organisational response fragmented. The problems were not, as popular mythology would later suggest, confined to the carbon fibre fan blades. They were systemic. The engine was being asked to achieve simultaneous breakthroughs in aerodynamics, materials science and manufacturing, any one of which would have been a formidable challenge in isolation. Together, they created a development program of unprecedented complexity. Early test runs achieved only approximately £34,000 of thrust against the guaranteed £42,000. The shortfall was enormous, £8,000, nearly 20% below the contracted figure. High-pressure turbine efficiency measured just 65%. Spool speeds were off design values. The engine was overweight. It consumed too much fuel. Every major performance parameter was wrong, and fixing any one of them risked making the others worse. The engineers were fighting a multi-front war with finite resources and a fixed deadline. As David Huddy's obituary would later clarify, with a candour that honoured the man's own honesty, Development problems have often been blamed wrongly on teething troubles with the new wonder material, carbon fibre. In fact, the scale of effort on design, trial and redesign in every element of the engine was unprecedented and had been unanticipated. The problems weren't in one component, they were everywhere. But the carbon fibre was the most visible catastrophe, and when it failed spectacularly. In May 1970, the Federal Aviation Administration conducted mandatory bird ingestion testing. This is exactly what it sounds like. 4-pound chickens, dead but otherwise intact, were fired at high speed into the 86-inch diameter high-fill fan blades while the engine ran at takeoff RPM. The test simulates what happens when a large bird flies into an engine during the most critical phase of flight. Every commercial engine must pass it. It is not optional. It is not negotiable. The high-fill blades shattered. The resin binding the carbon fibres on the thin leading edges couldn't absorb the impact. The composite material's anisotropic properties, strong along the fibre direction, weak across it, made it fatally vulnerable to the kind of sudden, non-uniform force that a bird strike delivers. The fan stage didn't just fail. It came apart. Pieces everywhere. Carbon fibre fan blades would not successfully enter airline service until the GE90 engine in 1995. 25 years, Lombard's concept was correct. Composite fan blades are now standard across the industry, lighter and stronger than anything titanium can offer. But in 1970, the materials science simply wasn't ready. The idea had arrived a quarter of a century too early, and Rolls-Royce had built its entire competitive position. The weight advantage that had won the Lockheed contract, the margin that was supposed to make the fixed price viable, on a technology that couldn't survive a chicken. The forced switch to titanium blades wiped out every advantage the carbon fibre had promised. Titanium was heavier, which meant redesigning the hub, the bearings, and the engine frame to handle the increased loads. The weight saving disappeared. The competitive edge over the CF6 and JT9D evaporated. And every hour spent on the redesign was an hour not spent solving the engine's other problems. The low thrust, the poor turbine efficiency, the excess fuel consumption. Development costs climbed like a fever chart. The original estimate of £65 million rose to £75 million, then to £135 million. By September 1970, the figure stood at £170.3 million, nearly triple the original projection. Meanwhile, the production cost per engine climbed to approximately £460,000 against the fixed contract price of $230,000. Every RB211 that Rolls-Royce built lost at minimum £110,000. Some estimates placed the loss per engine at $230,000, meaning the company was paying twice as much to build each engine as it received for selling it. The production line wasn't manufacturing engines. It was manufacturing bankruptcy, unit by unit, at industrial scale. Chapter 11. The Unravelling. In July 1970, David Huddy collapsed from exhaustion. The man who had flown 3 million miles selling an engine that was bleeding his company to death simply could not go on. He resigned in October, aged 54. His health never fully recovered. The personal cost of the RB211 was written on his body before it was written on the balance sheet. Denning Pearson, who had been assuring shareholders as late as July 1970 that the company had the resources to complete the RB211 program, resigned as chairman in November. He was replaced by Lord Cole, the former chairman of Unilever, brought in from outside the engineering world to provide the kind of financial and managerial discipline that the company's own culture had failed to generate. The government announced an additional £42 million in launching aid. But this was conditional on a satisfactory independent audit, and no money was ever actually paid. The Industrial Reorganisation Corporation, examining Rolls-Royce in 1969, had already found what it called manifest financial accountancy weakness. Lord Beeching and a Mr. Morrow were placed on the board to improve financial oversight. But the problems ran far deeper than bookkeeping. The company's culture was the problem. Rolls-Royce prized engineering excellence above all other virtues, above cost control, above schedule discipline, above the financial realities of a fixed-price contract. The engineers had always believed they could solve any technical problem if given enough time and resources. They had always been right. The Merlin had been improved from 790 horsepower to over 2,000. The Avon had served for 24 years. Every previous engine program had vindicated the culture of relentless refinement. But those programs had not been undertaken at fixed prices with delivery penalties attached. Those programs had been funded by governments at war or by military procurement contracts that absorbed cost overruns as the price of national defence. The RB211 was different. It was a commercial contract with a commercial airline's supply chain dependent on delivery dates. Every month of delay triggered penalty clauses. Every pound of excess development cost came directly from Rolls-Royce's own reserves. The culture of engineering perfectionism was colliding with the mathematics of commercial survival, and the mathematics were winning. A detail that captures the cultural gap. Rolls-Royce engineers examining a Pratt & Whitney engine during this period were appalled by the crudity of the engineering solutions. Crude joints, inelegant compromises, the kind of pragmatic shortcuts that made Royce's ghost shudder. But those same engineers were even more appalled that the competitor's engine worked. It worked, it was certified, it was flying, it was generating revenue. The JT9D was powering 747s across the Atlantic, while the RB211 was consuming cash in a test cell in Derby. On the 22nd of January 1971, Lord Cole told the Ministry of Aviation Supply that the RB211 programme could not continue under existing terms. On the 26th of January, the board decided, subject to consultations with the government and Lockheed, to end the project entirely. The losses, they concluded, were likely to exceed the net tangible assets of the company. Rolls-Royce wasn't just losing money on the RB211. It was losing more money than the company was worth. On Thursday, the 4th of February 1971, at 3:53 in the afternoon, Frederick Caulfield, the Minister of Aviation Supply, rose in the House of Commons. "I have to make a grave statement in regard to Rolls-Royce Limited." He announced the appointment of a receiver and manager. Trading in Rolls-Royce shares ceased immediately on the London Stock Exchange. The FT Industrial Index dropped 8.7 points. Tony Benn, speaking from the opposition benches, responded, "Is the right honourable gentleman aware that the collapse of Rolls-Royce and the statement that he has made constitute a major national tragedy for this country?" He was interrupted. Kenneth Lewis, a Conservative backbencher, shouted from his seat, "It is your fault." The receiver appointed was Rupert Nicholson of Peat Marwick Mitchell, the firm now known as KPMG. Nicholson was described as widely regarded as the best insolvency practitioner of his time. He would need to be. On that same day, Daniel Houghton, Lockheed's chairman, arrived in London with the legendary Skunkworks founder Kelly Johnson for what was supposed to be a routine quarterly review of the RB211 programme. Instead, they learned the engine company was dead. The reaction was seismic. 80,000 jobs at risk. An estimated 20,000 supplier companies affected. The MP for Derby South, standing in Parliament, gave the number that mattered most to his constituents. Does he appreciate that 80,000 jobs are at stake, 30,000 of them in my constituency? 4 days later, on the 8th of February, the full emergency debate consumed the House of Commons. Chancellor Anthony Barber confirmed the stakes in terms that no MP could misunderstand. Rolls-Royce activities are vital for our national defence, for without Rolls-Royce engines, many aircraft of the Royal Air Force would be grounded. Ian Lloyd, the Conservative MP for Portsmouth Langstone, delivered the speech that captured the paradox at the heart of the catastrophe. He traced the cost escalation, 65 million to 75 million to 135 million to 170 million, and called the financial control totally inadequate. Then he said, the thing that nobody in the chamber could refute. Perhaps the supreme irony of the situation is that Rolls-Royce at this moment is technologically ahead of both the United States and of Europe. The company hadn't failed because it built a bad engine. It had failed because it built one so far ahead of its time that the cost of getting there exceeded the resources of the company that dared to try. The political dimensions made the tragedy excruciating. Edward Heath's Conservative government had taken office in June 1970, pledged to free market principles. At the party conference that October, Trade Secretary John Davies had declared the government's philosophy in a phrase that became infamous. The country should be geared to people who are not lame ducks, who do not need a hand, who are quite capable of looking after their own interests. 8 months later, that same government was nationalising Rolls-Royce. In the House of Lords, one peer offered the epitaph, "It is all very well to refuse to help the little lame ducks on their way to market, but you cannot refuse help when an eagle falls exhausted at your feet because it has tried to soar too high." Chapter 12. The Men Who Had Won the War. The government chose a precise surgical course. Let the old company go bankrupt. Acquire the essential Aero engine, marine and industrial gas turbine assets through emergency legislation. Leave the shell company to absorb the Lockheed liabilities. Sell the profitable motorcar division separately. The Rolls-Royce Purchase Act. 1971 was introduced on the 8th of February, debated on the 11th, and received royal assent by late February. It was among the fastest pieces of major industrial legislation in modern parliamentary history. In May 1971, a new entity, Rolls-Royce 1971 Limited, was incorporated, acquiring the Aero engine assets from the receiver. But legislation doesn't build engines. Engineers do, and the engineers who saved the RB211 were not the young men of the jet age. They were the old men of the Merlin. Stanley Hooker, the mathematician who had transformed the Merlin supercharger, who had raised its adiabatic efficiency from 68 to 76%, who had designed the two-stage supercharger that kept Spitfires competitive against the Focke-Wulf 190, was persuaded out of retirement to serve as technical director. He was 63 years old. Hooker brought back Cyril Lovesey, who had supervised Merlin development at Derby throughout the war. Lovesey was over 70. He brought back Arthur Rubbra, another veteran of the Merlin programme, also over 70. These men had last worked together when Hitler's bombers were overhead, and the survival of the nation depended on whether a 27-litre engine could produce enough horsepower to keep Spitfires in the sky. Now, 3 decades later, they were back. The test cells at Derby were different, the technology was different, the challenge was different, but the engineering discipline was the same, the relentless, methodical, test and refine culture that Hives had built and Hooker had embodied. Identify the problem. Isolate it. Fix it. Test again. Don't theorise. Don't argue. Measure. One shop steward on the factory floor captured what every worker felt. We are fighting the Battle of Britain all over again. The renegotiated contract with Lockheed, hammered out by Frederick Caulfield in direct negotiations with Daniel Houghton, waived late delivery penalties and increased the price per engine by £110,000. But Lockheed itself was staggering. The C-5A Galaxy military transport programme had produced massive cost overruns. The TriStar was the company's bet on commercial survival, and without a working RB211, the TriStar was dead. If the TriStar was dead, Lockheed might follow. The Nixon administration sent the Emergency Loan Guarantee Act to Congress on the 13th of May, 1971, requesting $250 million in loan guarantees for Lockheed. Admiral Hyman Rickover, the father of the nuclear navy, condemned the measure in terms that echo across the decades. It represented, he said, a new philosophy where we privatise profits and socialise losses. The Senate deadlocked. The vote was tied. On the 2nd of August 1971, Vice President Spiro Agnew cast the deciding vote. The loan guarantees passed by a single ballot. The fate of 30,000 British jobs had ultimately turned on one American senator's decision to abstain. The RB211-22 received FAA type certification on the 14th of April 1972, approximately 1 year late. The first L1011. TriStar entered service with Eastern Airlines on the 26th of April 1972. The TriStar itself was a commercial disappointment. Only about 250 were built against original expectations of 1,400. But the engine was vindicated entirely. Its three-shaft architecture delivered exactly the efficiency, reliability, and growth potential that Lombard had predicted. The human cost was severe. Immediately after receivership, approximately 4,000 workers were laid off, mainly at Derby and in Scotland. Estimates suggested that 12,000 to 18,000 redundancies would have followed had the RB211 programme been cancelled entirely. Workers from Derby, Belfast, Watford, Leavesden and other sites sent deputations to Parliament. Philip Whitehead, the Labour MP for Derby North, gave voice to a suspicion that haunted his constituents. The government know that there is a widespread belief, particularly in my constituency, that the government decided to kill off the RB211 project and go for an exemplary bankruptcy. The suppliers suffered in silence. Firms that had delivered components, materials and services to Rolls-Royce on credit found themselves holding debts worth tens of millions of pounds. By February 1973, only approximately 15% had been paid back. Small subcontractor businesses faced bankruptcy within weeks. Businesses that had done nothing wrong, that had delivered exactly what was asked of them, and whose only mistake was trusting that the most famous name in British engineering would honour its invoices. Receiver Rupert Nicholson achieved what Roger Oldfield of KPMG later called the ultimate corporate restructuring, a CVA before CVAs were invented. Gross realisations totalled £350 million. The 80,000 shareholders eventually received 64.5p per share. It was better than nothing. It was a long way from what they'd been promised. The motorcar division was incorporated as Rolls-Royce Motors Limited on the 25th of April 1971, instructed to continue production without interruption. The spirit of ecstasy kept gliding down the Crewe production line while the Aero engine division was being rebuilt from the wreckage. Daniel Houghton continued as Lockheed chairman until February 1976, when he and vice-chairman Carl Kochian resigned over the Lockheed bribery scandals, revelations that the company had paid $22 million in bribes to foreign officials across Japan, the Netherlands, Germany, Italy and elsewhere. The company that had gambled everything on the TriStar was revealed to have gambled everything else on corruption. Chapter 13. The engine that won. The RB2. 11's redemption was total, not quick, total. The original RB211-22, delivering £41,000 of thrust, was joined by the RB211-524, producing between £50,000 and £60,600 of thrust, which powered the Boeing 747 for airlines that wanted an alternative to Pratt & Whitney's dominance. Then the RB211-535, delivering £37,400 to £43,100 of thrust, was selected for the Boeing 757, capturing 59% of all 757 engine deliveries. The 535 introduced the first hollow wide-chord unsnubbered fan blade, the very technology that the high-fill carbon fibre blades had tried and failed to deliver. Titanium, engineered with the lessons learned from the high-fill catastrophe, achieved what composite materials could not yet accomplish. By 1987, the RB211-524L had diverged so far from the original design that Rolls-Royce renamed it Trent, reviving the company's tradition of naming engines after rivers. The Trent family became the backbone of wide-body aviation. Trent 700 for the Airbus A330, Trent 800 for the Boeing 777, Trent 500 for the Airbus A340, Trent 900 for the Airbus A380, Trent 1000 for the Boeing 787, Trent XWB for the Airbus A350, the most efficient large turbofan ever built, Trent 7000 for the A330neo. Over 6,000 Trent engines are now in service, accumulating 200 million flight hours, carrying nearly 4 billion passengers. Every single one retains the signature three-spool architecture that Adrian Lombard conceived and that nearly destroyed the company that built it. Reprivatisation came on the 20th of May, 1987, under Margaret Thatcher's government. Shares were offered at 170 pence each. The public portion was 9 times oversubscribed. Market capitalisation at offering £1,362.5 million. The government retained a golden share to prevent hostile foreign takeover, a recognition that Rolls-Royce was not merely a company but a strategic national asset. At privatisation, Rolls-Royce held just 8% of the large civil turbofan market. By the year 2000, it had overtaken Pratt & Whitney in new orders. The motorcar division followed its own trajectory, and the final act carried its own painful irony. Rolls-Royce Motors was acquired by Vickers in 1980, then put up for sale in 1998. Volkswagen outbid BMW at £430 million but made a fatal error. The Rolls-Royce name and the interlocking RR logo were owned not by the car division but by Rolls-Royce plc, the aerospace company. BMW secured the brand licence for just £40 million. VW got the Crewe factory and the Bentley name. BMW built a new facility at Goodwood, West Sussex for £65 million, launching the new Phantom on the 1st of January 2003. The most famous brand name in engineering history was worth more than the factory that had built its products for 60 years. Chapter 14. The Marble Hall. The original Derby Works on Nightingale Road, the 12.7-acre site that Henry Royce designed in 1907, where every Battle of Britain Merlin was assembled, where the RB211 was developed, where the engine that bankrupted the company and then redeemed it was brought into the world, was deemed too small and too costly to modernise. Operations moved to the Sinn Féin campus on the southern edge of Derby. The Nightingale Road factory closed in March 2008. By 2014, every factory building had been demolished. The machine shops where apprentices had learned to hold tolerances measured in thousandths of an inch. The test cells where Merlins had first run and where the RB211 had failed and then, painfully, succeeded. The drawing offices where Henry Royce's specifications had been translated into the most consequential engines in aviation history. Gone. Cleared. The ground levelled for redevelopment. Only one structure survives. The Marble Hall, the 1912 commercial block, remodelled in 1938 with Portland stone and Tuscan polished limestone columns, Hopton woodstone floors, and a ramped double staircase where customers once climbed to collect their finished motor cars. It is Grade 2 listed. It houses offices for startups now. The Battle of Britain Memorial Window, stained glass designed by Hugh Easton, unveiled in 1949 by Lord Tedder in the Marble Hall itself, has been removed to safe storage. A plaque installed in 2017 commemorates the 23 people killed in the 1942 bombing. Henry Royce had designed the factory windows at a height that made watching outside difficult, so workers wouldn't waste time looking. Nobody looks out those windows now. There are no windows left to look through. At Crewe, the shadow factory has fared better, though its identity has transformed beyond recognition. The buildings that were raised on potato fields and camouflaged to look like streets from the air are now the headquarters of Bentley Motors under Volkswagen ownership. VW invested £500 million in the first 2 years after the 1998 takeover. The site covers 5.6 million square feet. It is the UK's only carbon-neutral luxury car factory. Over 4,000 people work there, hand-stitching leather interiors and assembling Continental GTs, where Merlins once emerged at the rate of hundreds per week. The Rolls-Royce 5, 8-engine lineage, the 6.75-litre unit, first designed in 1959, lives on in modified Bentley form, the longest-serving engine architecture still in production anywhere in the world. Rolls-Royce plc maintains its global headquarters in Derby, the Sinn Féin Aerospace Campus, the Rainsway Submarine Reactor Facility expanding for the AUKUS programme. Total Derby employment, estimated at 12 to 14,000. Globally, the company employs 42,400 people, generates £17.8 billion in revenue, holds an order backlog of £82.1 billion, and operates in 48 countries. A 7-ton Trent 1000 engine hangs suspended from the ceiling of Derby's Museum of Making, housed in the Silk Mill, the world's first factory, built in 1718. 300 years of British industrial making compressed into a single image. The Rolls-Royce Heritage Trust, founded in 1981, preserves what the company itself has moved on from. 5 branches and over 1,700 members worldwide. The Heritage and Future exhibition at the Derby Aerospace campus displays over 30 engines, from Eagle to Trent XW. B. The company still owns and flies a Spitfire PR-19, serial PS853, at air shows across Britain. The Merlin's exhaust note, that unmistakable deep-throated roar, still fills the sky above summer crowds who stand with their faces turned upward, watching something that was built in the factory that no longer exists. In Scotland, oral histories from Hillington workers document the human cost of the years after 1971. Colin MacDonald, who had trained colleagues at Rolls-Royce sites across the world, recalled the betrayal of the post-bankruptcy redundancies with a single phrase. We had bent over backwards. 5 words. They carry the weight of a career given and a career discarded. The compressed arc is almost unbearable in its symmetry. A company founded with £60,000 in 1906 by a self-taught orphan and a baron's son. The engine that won the Battle of Britain. The car driven by kings. The brand known to more people on Earth than any name except Coca-Cola. Then a single engine, revolutionary, brilliant, ruinously ambitious, and a fixed-price contract signed without the one engineer whose judgment might have held the costs in check. £110,000 lost on every engine delivered. 80,000 jobs swaying over the abyss. A Conservative government that had sworn it would never rescue lame ducks, nationalising the company within days. The engine that bankrupted the company sired the family that now dominates world aviation. The Trent engines carry 4 billion passengers on the 3-spool architecture that Lombard designed, and the 1971 bankruptcy nearly killed. The factory where it all happened has been demolished, and only the marble hall remains, limestone columns holding up a ceiling in an empty postcode, the last physical trace of the place where Henry Royce's perfectionism, and Adrian Lombard's ambition, and Ernest Hives's ferocity, and Stanley Hooker's mathematics, and Agnes MacLean's courage, and the hands of 168,000 Merlin builders all converged into the greatest engineering company Britain ever produced. The boy from the poorhouse built something that outlived him. The engine that destroyed his company proved him right. And the factory where it happened is gone. Every wall, every window, every test cell, every drawing office. Gone. Except for the marble hall, standing alone in the quiet, with its limestone columns and its empty staircase and its memory of what it meant. Once, to build something under the name of Rolls-Royce.